Good evening. Good evening. K.V.S.S.Sarma, Physics faculty. Today I am going to discuss a KCET paper. One KCET model paper I am going to discuss today. Before going into the paper, I will briefly tell you about the Unacademy Plus subscription. Okay. So now we are attending the 3 YouTube classes. Along with them, you can attend the special classes also. So I used to take special classes from evening 4:30 to 5:30. In that special class, I am discussing now presently waves and sound I am discussing. You can attend those classes, they are free. Okay. So but okay. So if you want to take the Unacademy class subscription, why you should take, I will tell you. It is very useful for the students who are preparing for 2021 KCET, mains and bids type of exams. You can attend all the regular classes of all the 3 subjects, maths, physics, chemistry, and biology also you can attend. So daily we'll have 2 to 3 hours of teaching every subject, almost 20 hours per month, and the 12 months plan is just 12,375 rupees is the 12 months plan, and 6 months plan is just 10,125 rupees for all the 4 subjects. Okay, for a trial price you can take for 1 month it is 2250. After getting discount, for availing the discount, you have to use the code KVSS live. If you use the code KVSS live, you will get the required the necessary discount you will get. Okay, so the advantage is you can attend all the regular classes, premium content at affordable price, complete coaching for KCET or BITS or mains you're getting just for 12,375 rupees. Okay, so and well structured live courses and dedicated live doubt clearing session. All the classes are live classes, and during live class also you can ask the doubts. You can send message by using the chat option. You can ask the doubts, you can upload the questions. After every 3 classes you will get a doubts clearing session in which you can ask the doubts. Okay, so this complete all the topics will be covered in this. At the end of the topic, doubts clarification, will provide you assignments, DPPs, and weekend quizzes, everything. So single subscription with will give you unlimited access. Okay, so this is the set of the faculty that are taking the plus classes now. Physics I am taking, chemistry, mathematics, and botany remaining faculty are taking. Okay, so in this complete syllabus is covered, and tips and tricks by the top educators. Topic wise practice questions will be given, and full length mock test will be completed. Okay, will be discussed. So now yes, now we'll start the discussion of the KCET paper. So last class I discussed a few questions from mechanics. So I will go to the electricity part. Today I will discuss questions from electricity. So we'll start from the question number 15. See the 15th question. See the 15th question. The equation of a plane progressive wave is y is equal to 0.9 sine 4 pi into t minus x by 2. When it is reflected at a rigid support, its amplitude becomes 2/3 of its previous value. Equation of the reflected wave. Okay, so the equation of the reflected wave is given by Amplitude of the incident wave is 0.9. Amplitude of the reflected wave is 2/3 of its previous value. Okay. The wave is reflected from a rigid support. So there is a change in phase of pi radians. So 2 by 3 into 0.9, that is 0.6. So if the equation of the incident wave is A sine omega t minus kx, then the equation of the reflected wave is given by A r sine omega t plus kx plus pi. Whenever wave is reflected from a rigid end, it undergoes a phase change of pi radians, sine omega t plus kx plus pi. So for this problem, the displacement equation of the reflected wave is 0.6 sine 4 pi omega t plus kx plus pi. So sine 180 plus theta is minus sine theta. So we will get minus 0. Second option you will get sine 4 pi into t minus x by 2. Okay. So like this you can solve the problem number 15. So the answer is 2. Next. The 16th problem. A positive point charge Q is brought near isolated metal cube. So whether it is a metal cube or sphere shape, anything. So this is neutral sphere and a point charge Q is kept near it. Now due to electrostatic induction, so this side you will get negative charge. It is a cube or sphere, same you will get. And other side you will get positive charge. Farther side will get positive charge due to electrostatic induction. But inside there will be no charge. Inner surface is charge free. Inner surface is charge free. Okay. So no charge will come on the inner surface. You will get charge only on the outer surface. So this is non-uniformly distributed. The charge on the outer sphere is non-uniformly distributed. So the interior remains charge free and the surface gets non-uniform charge distribution. See the 17th question. Okay, for 17th question. When the separation between two like charges is increased, the electrostatic potential energy. Can anyone try this? Anyone is there? Can you try this and post the answer? Suppose like charges, I will take both plus Q1 and plus Q2. And the separation is R. Therefore, the formula for potential energy is given by K, 1 by 4 pi epsilon naught. K Q1 Q2 by R is the formula for P. Okay. Now what you are doing, separation between two like charges is increased. Separation like charges is increased. So if increase R value, because R is in the denominator, if R increases, U value will decrease. Okay, so potential energy of the system will decrease. Potential energy of the system decreases. Now we will discuss 18th one. Okay, 17th is over. We'll discuss 18th one. A particle of mass m and charge q is placed at rest in uniform electric field E and then released. So, charge is q, mass of the particle is m. So, there is a uniform electric field E. So, because of this uniform electric field, it experiences a force QE. Force acting on the charged particle is QE. Because of this force, it gets accelerated. The kinetic energy attained by the particle after moving a distance y is. So it moves a distance y. After moving a distance y, the kinetic energy gain. Work done by electric field is force into displacement into cos theta. Force and displacement both are in the same direction. So force is QE, displacement is y. QE by cos 0 is 1. So this is the gain in kinetic energy. This is equal to final KE minus initial KE. So therefore, the final kinetic energy of the charged particle is QEY. QEY is the kinetic energy of the charged particle. The kinetic energy attained by the particle after moving a distance y. Yeah, let us look at the 19th problem. 19th one. What is the effective capacitance between the points x and y? I think so. This point is x. Effective capacitance between the points x and y. So here there are 5 capacitors. So we will get in the form of a Wheaton bridge. Sorry. So we'll get in the form of a Wheaton bridge. So I will write A, B, C. Totally have 4 junctions. I will mark. Okay, sorry. So this point is A and this point is B. This is C and this is, you have 4 junctions. So X and Y same. First one, 6 microfarad between A and B. Sorry, A, B, C, D. Opposite is A, B. AC, AB. AC. This is D. This is D. This is B. Okay. So first one, here I am marking A here. Last point is D. This point is B and this point is C. So first one, 6 microfarad is in between A and B. This is 6 microfarad between A and B. Between A and C also 6 microfarad. This also 6 microfarad. This one over, this one over. Next, between B and C, 20 microfarad. This is 20 between B and C. Between C and D, 6 microfarad. This is also 6 microfarad between C and D. Between B and D also 6 microfarad. So P by Q is equal to R by. It is a balanced Wheatstone bridge. So it is a balanced Wheatstone bridge. Okay, it is a balanced Wheatstone bridge. Therefore, this will become ineffective. This 20 microfarad becomes ineffective. 6 and 6 series 3 microfarad. 6 and 6 series 3 microfarad. Total is 3 plus 3. 6 microfarad is the effective capacity. So answer is fourth one. Okay. Next, look at the problem number 20. Okay, problem number 20. So, two charges of magnitude Q and minus 3Q are placed at 100 centimeter apart. Distance from plus Q between the charges where the electrostatic potential energy is 0. So, this is Q. This is minus 3Q. Suppose at this point electrostatic potential energy 0, potential is 0. Potential energy is potential per unit charge. Okay. Suppose this distance is x and this distance will be 100 minus x. So here potential should be 0. That means V1 should, because this is producing positive, this is producing negative potential, or you can take directly total potential is kq by x. Because of this kq by x plus because of this k into minus 3q. Minus 3q by 100 minus x. This must be 0. Total potential should be 0. So you will get kq by x is equal to 3kq by 100 minus x. So kq cancel. You will get 100 minus x is equal to 3x. X is equal to 100 by 4. 25 centimeters. So where x is equal to 25 centimeters, the electrostatic potential is 0, hence potential energy is also 0. And now we will go to problem number 21. Understood? Any doubt in this? So can you try problem number 21? Students, can you try to tell the answer for problem number 21? Try problem number 21. Try to post the answer. In the figure, two conducting concentric spherical shells are shown. Electric potential at the center is 20 volt. At the center potential is 20 volt. And the electric potential of the outer shell is 5 volt. Then the potential of the inner shell is. Can you try the answer? Potential of the inner shell is how much? At the center potential is 20 volt. Can anyone try this? Potential at the center is 20 volt. Then the electric potential of the outer shell is 5 volt. Potential of the inner shell. We have one shell here. This is inner shell. Another one is outer shell. Okay, hedging them to be shells. So here potential is given 20. Because from here to here electric field 0. So therefore there is no change in potential. Because electric field is 0, potential is constant. So in this region, the inside region, potential remains constant. Therefore potential on the surface of inner sphere is equal to same 20 volt. Because here the electric field must be constant. Okay. 20 volt is the answer. Understood? If there is no electric field, potential must be constant. And next 22 complex, slightly complex circuit. Can you try 22? Nivan, can you do 22 problem? So this is called junction removal method. We'll draw the circuit once. So this is a problem based on junction removal method. You have to find potential effect resistance across A and B, each one go. So if you draw one line joining A and B, if you draw a line joining A and B, it is not line of symmetry. First you have to check that. So circuit is not symmetric about the line AB. Then you draw one perpendicular to AB, perpendicular bisector of AB, and check it. So circuit is symmetric. One side of the circuit is exactly same as the other side of the circuit. This is half, this is half. So one side of the circuit is, suppose the left side and right side if I take. This is the mirror image of the left side. So it can call, this is mirror image method or junction removal method. So if one half of the circuit is exactly symmetric with respect to other one, then you can remove this junction. This junction is unnecessarily made. So what he can do is, he can remove this junction. He can connect the wires directly like this. Okay, so here this junction is not required. So you will get the circuit like this. Directly A to B. Okay, and here you can remove this junction. So now this is 1, this is 1. 1 and 1 series. 2. 2 and 1 parallel. 2 into 1 by 2 plus 1. So 2 by 3 ohms. For 2 by 3. So this is 1 plus 2 by 3 plus 1. They are in series. 1, 2 by 3 and 1. So this is 8 by 3. Okay. And this one 2 ohms. Other root 1 plus 1, 2 ohms. So 8 by 3 and 2 ohms are in series and in parallel. Therefore effective resistance across AB is equal to 2 into 8 by 3 by 2 plus 8 by 3. So this is 16 by 3 by 3 into 6 plus 14 by 3. So this is 16 by 14. If you divide by 2, 8 by 7. Okay. So the effective resistance across AB is equal to 8 by 7 ohms. This is called junction removal method. So if one half of the circuit, you have to draw a line by joining A and B. If the circuit is symmetric about AB, then all points lying on the perpendiculars will be at same potential. If it is not symmetric about AP, draw another line perpendicular to AP, perpendicular bisector. Then if one half of the circuit is symmetric about the other half, then you can remove the junctions which are there on that line. This junction you can remove. In our 23 simple only Kirchhoff voltage law is a consequence of law of conservation of energy. So I will do 24th problem. Okay. So problem number 24. So two electric bulbs whose resistances are in the ratio 1:2. So resistance of the first bulb by resistance of the second bulb is 1/2. Are connected in parallel across a voltage source. Okay, suppose this is B1, this is B2. Both bulbs are in parallel. The powers developed in them are in the ratio. So, power consumed by first bulb by power consumed by second bulb is equal to how much? So, can you try and put the answer? Anyone? So, generally, many students used to do like this. Okay. So, generally, they use the formula P is equal to I square R. P is equal to VI or I square R. If you use this formula, you will get P1 by P2 is equal to R1 by R2 is equal to 1/2. But this is wrong because current is not same. When they are in parallel, current will be different. Current is not same. Okay, currents are different. But voltage is same because they are in parallel. Voltage across the bulbs will be same. So you have to use the formula P is equal to V square by R. This formula you have to use. You should not use P is equal to I square R. So now what answer you will get? You will get P1 by P2 is equal to R2 by R1. So this is 2:1. This is correct. Okay. So 2:1 is the correct answer. We'll discuss some good questions. We'll do question number 29. And another 4-5 minutes only. So 29. So next class I am going to take on YouTube on 20th. On 20th I am going to discuss waves and sound. Briefly I will discuss, but daily maybe tomorrow I am taking 4:30 to 5:30. I am taking a special class on waves and sound only. I will discuss the Doppler effect part. So that is a free class you can attend. Students you can attend that 4:30 to 5:30 class. So in 29th, proton, neutron, one is proton, other is neutron, H2. Neutron and alpha particle enter into same magnetic field with the same momentum. So P value same, momentum is same, and perpendicular to the field. Ratio of radii of the circular path. So the formula for radius of the circular path is R is equal to R is equal to mv by bq, which is also P by bq. R is equal to P by bq. P is momentum. Okay, so this implies just R is inversely proportional to Q. Okay, R is inversely proportional to Q. So ratio of radii of the proton, neutron and alpha particle. 1 by charge on the proton is 1 unit, 1 by charge on the neutron also 1 unit, 1 by charge on the alpha particle is 2 units. Alpha particle is having 2 units charge and 4 units mass. So if you multiply with 2, you will get 2:2 2:1. This is the ratio, 2:2:1. Okay. Now let us see question number 20, 29, okay, 30. We did 29. You can do question number 30. Okay. A cylindrical conductor having radius of cross section capital R carries a steady current I. If the distance from the axis of the conductor is smaller, then the magnetic field B. I am drawing the side view of the cylinder. So R is the radius of the cylinder. Small r is a point. So the formula for magnetic field is, if small r is less than capital R, for inside point, the magnetic field is given by mu naught I by 2 pi capital R square into small r. Okay. So this implies B is proportional to R. B value is proportional to for a small r less than R. For outside point, equals you can write. For small r greater than or equal to capital R, formula for B is mu naught I by 2 pi small r. Okay. So from this you can write B is proportional to 1 by R. Therefore, for small r less than capital R, directly proportional to R. For small r greater than capital R, inversely proportional to R. Okay. So like this you can do the problems. So thank you for attending this class. The old slide, my mistake happened. So take the plus subscription to attend the free classes. Thank you.